Good day everyone. So for now, I am going to report about the measure of variability. But before anything else, we must identify first what is variability.
So, what is variability?
So variability, it refers to how spread apart the values or observation of the distribution are how much the values observation vary from each other. There are four measures of variability: the range, the mean absolute deviation, variance, and standard deviation. As what I have said, there are four measurements of variability: the range, the mean absolute deviation, variance, and standard deviation. So, first, we must identify what is range.
So, what is range?
Range is the difference between the highest value and the lowest value. It is the simplest measure of the variability to calculate. And to find the range, it is uses by the formula. It is range is equal to the highest minus lowest.
So, let us now the example. So, in example number 1, mathematics achievement test scores are 60, 75, 80, 85, 90, and 95. So, find the range. So, here's the solution. But before that, we must follow our given formula, which is the range is equal to the highest minus lowest. So, as what I have seen, the highest score are 95 minus the lowest score, which is 60. So, 95 minus 60 is 35. So, therefore, our range is 35. So, here's the second example. A data set with 10 numbers: 199, 145, 123, 167, 145, 191, 182, 178, 162, and 151. So, what is the range? So, here's the solution. First, we must follow the given formula. The range is equal to the highest minus lowest. So, first, we must identify what is the highest number. So, the highest number is 199. So, copy the 199 minus the lowest number, which is the 123. So, 123. So, 199 minus 123 is equal to 76. Therefore, our range is 76. So, here's the third example. Given the frequency distribution table below, compute for R. So, scores of 40 students in a 60-point quiz. So, try to observe the table below. So, first step of finding the range is to get the value of CB or the class boundaries. So, in getting the value of class boundaries, we must identify the lower limit and the upper limit. So, meron tayong tinatawag na upper and lower limit. So, makikita ang lower at upper limit is in this row. So, for example, in the first box, 53 and 58, the lower limit is the 53, while the upper limit is 58. So, in getting the CB or the class boundaries, we must identify the lower and upper limit. So, when we are finding the lower limit, which is the 53, is subtract natin sa 0.5. So, for example, 53 minus 0.5 is 52.5. While, kung hahanapin naman natin ang upper limit, which is the 53, is i-add natin ito sa 0.5, which is 58 plus 0.5 is 58.5. So, ipapalaw lang natin yung step na ginawa natin. So, kagaya lang din dito sa next box. So, the upper limit, first, the lower limit is 47. 47 minus 0.5 is 46.5. And, hanapin naman natin yung upper limit, which is 52. So, i-add natin ito sa 0.5. So, 52 plus 0.5 is 52.5. So, ganung step lang din ang gagawin natin dito pababa. So, in the third box, 41, 41, and 46. So, just follow the steps. So, 41 minus 0.5 is 40.5. Then, 46 plus 0.5 is 46.5. And in the next box, 35 minus 0.5 is 34.5. Then, 40 plus 0.5 is 40.5. And another next. So, 29 minus 0.5 is 28.5. Then, 34 plus 0.5 is 34.5. And 23 minus 0.5 is 22.5. And 28 plus 0.5 is 28.5. 17 minus 0.5 is 16.5. So, 22 plus 0.5 is 22.5. 11 minus 0.5 is 10.5. And 16 plus 0.5 is 16.5. Then 5 minus 0.5 is 4.5. And 10 plus 0.5 is 10.5. So, ganun lang kasimple. So, as we see, na-complete na natin yung table. So follow na tayo sa second step, which is following the given formula. So, as what I've said lately, the formula is the range is equal to the highest minus lowest. So, ganun lang din ang gagawin natin nung una. So, identify the highest score and the lowest score. So, the highest score is 58.5, while the lowest score or the lowest number is 4.5. So, ima-minus natin yung 58.5 minus 4.5 is equal to 54. Therefore, our range is 54.
So let's proceed to the next topic, which is the mean absolute deviation or MAD.
So, what is mean absolute deviation? Mean absolute deviation or MAD is the average distance between each observation and the mean. It gives us an idea about the variability in the data set. So, to find the mean absolute deviation, it followed by steps. So, here's the following steps. So, for the step 1, to find the mean, add all the elements of the data set or add all numbers of elements in the data set, then divide it by the number of set. Then the second step, calculate how far each element is away from the mean. Use the absolute value because distance is always positive. And the third step is add deviations. Then the fourth step or the last step, divide the sum by the number of data points. So let us know the examples. So in example number 1, a group of mountaineers went on hiking to Mount Pulag, Philippines, to study the different species of plants existing in the area. The ages of the mountaineers are 34, 35, 45, 46, 49, and 32. So what is the MAD or the mean absolute deviation of their ages? So reminders, to find the MAD or the mean absolute deviation, we must follow the four steps of finding the deviation. First step, find the mean. So to find the mean, add all the elements of the data set, then divide it by the number of set. So here's the elements of the data set: 34, 35, 45, 46, 49, and 32. So according to step 1, add all the elements of the set. So mean is equal to elements of the data set, then divide it by the number of set, which is 6, because 1, 2, 3, 4, 5, 6. So 6 divides 6. So add all the elements of the data set, which is 34 plus 35 plus 45 plus 46 plus 49 plus 32 is equal to 241. Then divided by 6, which is the number of set. So 241 divide 6 is equal to 40.17. So let's proceed to the step 2. So which is distance from the mean is equal to each number minus mean. So calculate how far each element is away from the mean. Use the absolute value because distance is always positive. So according to step 2, each number minus mean. So each number minus the mean. So for example, 34 minus 40.17. So negative 6.17. So when we say mean, walang negative basta sa mean. So it turns to 6.17. Positive 6.17. So let's just follow what the steps are. So let's proceed. 35 minus the mean, 40.17 is equal to negative 5.17. Then it turns to 5.17. Then 45 minus the mean is 4.83. Then still 4.83. Then 46 minus the mean is 5.83. Then still 5.83. Then 49 minus the mean, 40.17 is 8.83. So the last one, 32 minus the mean, 40 minus 0.17 is equal to negative 8.17. So it turns into positive 8.17. So let's proceed to the step 3, which is add deviation. So all we need to do is to add all the answers. So 6.17 plus 5.17 plus 4.83 plus 5.83 plus 8.83 plus 8.17 is equal to 39. So this is now the answer, 39. So let us now proceed to the step 4, which is divide the sum by the number of data points. So copy the sum, the 39, then divided by 6, which is the number of data points. So 39 divide 6 is equal to 6.5. Then if we're going to round off 6.5, it will become 7. It will become 7. So therefore, the mean absolute deviation is 7 years old. So in a group data, the X is not given, only the class interval and the frequency. So we are going to create 2 additional columns for X and the C of Fx. So here's the 2 additional columns, the X and the C of X. So X is the mean value of the class interval. So for each of the class intervals, we shall calculate the mean value to represent the X. Calculate the mean value to represent the X. So we start for the first class interval, the 53 and 58. So by the way, we should add these 2 intervals, then we divided it by 2. So 53 plus 58 is equal to 111. Divided by 2 is equal to 55.5. Then 47 plus 52 divided 2 is 49.5. Then followed by 41 plus 46 divided 2 is 43.5. Then 35 plus 40 divided 2 is equal to 37.5. Then 29 plus 34 divided 2 is 31.5. Then 23 plus 28 divided 2 is equal to 25.5. Then 17 plus 22 divided 2 is equal to 19.5. Then 11 plus 16 divided 2 is equal to 13.5. Then lastly, 5 plus 10 divided 2 is equal to 7.5. So we have gotten the mean values which represent the X column. So we go ahead to calculate the C of Fx. So by the way, Fx means frequency multiplied by by the value of, by the mean value, which is the x. So, for the first row, 3 times 55.5 is equal to 166.5. Then 4 times 49.5 is equal to 198. Then 1 times 43.5 is equal to 43.5. Then 2 times 37.5 is equal to 75. Then 10 times 31.5 is equal to 315. Then next, 11 times 25.5 is equal to 280.5. Then 4 times 19.5 is equal to 78. Then 3 times 13.5 is equal to 40.5. Then lastly, the 2 times 7.5 is equal to 15. So next, we shall sum up, or we need to sum up the frequency and the product of the frequency and the x, which is the C of fx. So all we need to do is to add all the values of the frequency and the C of fx. Thus, the frequency is equal to 40, while the C of fx is equal to 30.3. So this x bar is represented by the mean. So let us proceed now to the mean deviation. So for our mean deviation, our formula is summation of absolute value of x minus the x bar over or divided by the summation of f. So now we need to get the value of x minus x bar. So x bar means the mean of distribution we calculated earlier, which is the 30.3. So we need to add additional columns for x minus x bar. So here's the column for the x minus x bar, but we need to add another next column for CF into x minus x bar. So to get the value of x minus x bar, we need to subtract the value of x into the x bar or the mean. So first, 55.5 minus the value of mean, which is the 30.3, is equal to 25.2. Then next is 49.5 minus 30.3 is equal to 19.2. Then 43.5 minus 30.3 is equal to 13.2. And the 37.5 minus 30.3 is equal to 7.2. Then next is 31.5 minus 30.3 is equal to 1.2. Then 25.5 minus 30.3 is equal to 4.8. Then 19.5 minus 30.3 is equal to 10.8. Then 13.5 minus 30.3 is equal to 16.8. Then lastly, the 7.5 minus 30.3 is equal to 22.8. So now, since we completed the column of x minus x bar, so let's proceed to the next column, which is the CF into x minus x bar. So to get this column, we should multiply the frequency by the x minus x bar, which is this column. So now let's start multiplying. So let's start from the 3. 3 times 25.2 is equal to 75.6. Then 4 times 19.2 is equal to 76.8. Then 1 times 13.2 is equal to 13.2. Then 2 times 7.2 is equal to 14.4. The next 10 times 1.2 is equal to 12. So 11 times 4.8 is equal to 52.8. Then 4 times 10.8 is equal to 43.2. Then 3 times 16.8 is equal to 50.4. Then lastly, the 2 times 22.8 is equal to 45.6. So next thing to do is to add all the value of this column to give us the summation of CF into the x minus x bar. So let's sum up, or let's add. So we have 384. So therefore, the summation of CF into x minus x bar is equal to 384. So in the last part, we need to substitute the values of the given formula, which is the mean deviation is equal to the summation of CF into the x minus x bar over n. So therefore, we have 384 over 40 because our n is 40. So 384 divided by 40 is 9.6. Then if we are going to round off the 9.6, then it will become 10. So therefore, the main absolute deviation of the scores of the students is approximately.
So now, since we are done in mean absolute deviation, so let us proceed to the next topic, which is the variance.
So what is variance?
So variance is the average of the square deviations of the set of observation from the mean. It measures how far a data set is spread out.
Variance is presented as sample squared, where S represented as a sample deviation and squared is a variance of the sample, and it's equal to the sum of the square differences between the data point and the sample mean represented by the variable x bar divided by the n minus 1, where n is the size of the sample. So let us now the example. Now let's calculate the variance given these numbers: 6, 9, 14, 10, 5, 8, and 11. So first, we're gonna list the data in column. So I already put the list of all the data. So dapat mauna yung maliit papunta sa malaki number. So in the next column, we're gonna put the difference between each data point and the same sample mean, and then the square difference between each data point and the sample mean. Now let's calculate the sample mean. The sample mean is basically the average, is equal to the sum of the data points divided by n, which is the points that what we have. So first, let's take the sum of this number, the whole data. So 5 plus 6 plus 8 plus 9 plus 10 plus 11 plus 14 is equal to 63. So this is represent of all the data points that we have. So it is 63 over or divided by the number of data that we have. So 1, 2, 3, 4, 5, 6, 7. So it is 7. So 63 divided 7 is equal to 9. So 9. So this is our sample mean. 9 is our sample mean. So what we're gonna do next is we're gonna subtract each data point by our sample mean, our 9. So, 5 minus 9 is equal to negative 4. And 6 minus 9 is equal to negative 3. And 8 minus 9 is equal to negative 1. And 9 minus 9 is equal to 0. And 10 minus 9 is equal to 1. And 11 minus 9 is equal to 2. And 14 minus 9 is equal to 5. Now, we're gonna do next. We're gonna take the squares of those difference. We're gonna take this to become, we're gonna take this to become squares. So negative 4 square is 16. And the square of negative 3 is positive 9. Then the square of negative 1 is positive 1. Then the square of 0 is just still 0. And the square of 1 is 1. Then the square of 2 is 4. Then lastly, the square of 5 is 25. So keep in mind that the variance is going to be the sum of the squares differences between each data point and the sample mean divided to n minus 1. So to get this part of the formula, we simply need to get the sum of this column. We're gonna add all of the value of this column. So 16 plus 9 plus 1 plus 0 plus 1 plus 4 plus 25 is equal 56. So let's put the 56 over there over n minus 1. So our n will be the number of data. So it's 7 because 1, 2, 3, 4, 5, 6, 7. So there are 7. So our n is 7 minus 1. So 7 minus 1 is equal to 6. Then let's divide the 56 to the 6. So 56 divided 6 is equal to 9.3. So 9.3. And this is our variance of the sample. So 9.3 are our variance.